we continue our discussion on Dirac delta function, its properties and some problems. We have derived already the property which is delta of x equal to delta of minus x, implying that Dirac delta function is an even function, and the first derivative, which is denoted by delta prime of x, was proved to be equal to minus of delta prime of minus x, which is equal to minus of delta x by x. And this means that the first derivative of Dirac delta function, that is delta prime of x, is an odd function. Let us now address a few problems. And the first problem is find the value of x, Dirac delta of x, for x equal to 0. And let us come to the answer. X delta of x for x equal to 0, and therefore let us put 0 for x, and we have to put the value of delta x at x equal to 0, which is obviously infinity, so it is 0 into infinity. Now the number 0 is a fixed number, and what about infinity? Infinity is not a fixed number. It is different for different people. It is a very large arbitrary number. Let us give some example. Say 10 can be taken to be infinity if I count up to 9 and cannot count thereafter. So 9 is the limit, and above it we have 10, so 10 is the infinity in our case, and 0 into 10, which is infinity, is 0. Let us take another instance. Suppose we are smart enough and we count up to 10 raised to the power 1000, and we cannot count any more. We do not wish to count any more. So 10 to the power 1000 is infinity in our case, and 0 into 10 to the power 1000, which is infinity, is 0. So in both cases the product is 0, and therefore 0 into infinity is 0. So what we get is x delta x is 0 for x equal to 0 as wanted in the problem. We come to the second problem now. Which is prove that x square delta prime of x equal to 0. But x square delta double prime of x is twice of delta of x, prime indicating first derivative and double prime indicating second derivative. Let us come to the answer now. We got the result x delta prime of x is equal to minus of Dirac delta of x, and let us multiply by x to get x square delta prime of x equal to minus of x delta x. And again we got in the previous video the relation x delta x equal to 0, and this happens always, that is both for x equal to 0 as well as for x not equal to 0. So putting 0 for x delta x, we have x square delta prime of x equal to 0. Which is the first relation of the second problem. Now the left hand side of the second relation is x square delta double prime of x, which means we have to differentiate this relation x square delta prime of x. So we take derivative with respect to x to get d dx of x square delta prime of x d dx of 0, which is 0. So the left hand side is split into two terms, which are x square d dx of delta prime of x, the first term, and the second term is delta prime of x into d dx of x square. This is equal to 0. Now d dx of delta prime of x can be designated by delta double prime of x, it being the double derivative, and d dx of x square is twice of x. So let us write it as x square delta double prime of x plus 2x delta prime of x equal to 0. Rearranging, we get now let us use the relation that we earlier got, x delta prime of x equal to minus of delta x, and therefore we end up with x square delta double prime of x equal to minus 2 into minus of delta x. Minus minus cancels out, and therefore we end up with twice delta x. So the second relation, namely x square delta double prime of x equal to twice delta x, is proved.